All right, for lesson 1-3, it was comparing and ordering real numbers. So the objective was to be able to compare and order rational and irrational numbers. Example number 1, approximate an irrational number. So they gave us an irrational number for this, and we need to approximate it as a decimal. So Darcy wants to add this purple ribbon, that's 8.5 feet, onto this diagonal of her flag that she is designing. Her diagonal is the square root of 74, and we would need to know if this 8.5 foot ribbon is going to fit on our diagonal. So in order to figure that out, I need to know what the square root of 74 is. For this, you're not going to be allowed to use a calculator for this entire first unit, so everything that we do today is going to be by hand. I'm going to be doing a lot of the math off the screen, so when we get to multiplication problems, I want you guys to pause it, do it on your own, and then check your answer with my work. So we're going to start with the square root of 74. Thinking of my perfect squares, I know that it's going to fall in between 64, which is a perfect square, and 81, which is a perfect square. I know that the square root of 64 is 8, and the square root of 81 is 9. So it's going to be a decimal somewhere in between there. Since it's going to be a decimal, I'm going to be looking at my tenths place. I'm just going to start with 8.5. It's right in the middle, and it'll be a good starting point for us. So I'm going to go ahead and multiply this. Go ahead and pause your screen, work it out. All right, once I worked it out, I ended up with 72.25. Now that's too small, so I'm going to go up to the next decimal point, which is 8.6 squared. So I'm going to do 8.6 times 8.6. Again, write that problem down, work it out. The answer that I got was 73.96. Now that is very close to our square root of 74, so I'm going to use 8.6 as my estimation. Now, since I only have 8.5 feet of ribbon, and I need at least 8.6 if I'm using it as an approximation, I do not, or Darcy does not have enough ribbon. Okay, because the square root of 74 is greater than 8.5. Okay. All right. The second example is comparing irrational numbers. So they're giving us two irrational numbers, imperfect square and a non-terminating decimal, and we want to plot them on a number line. So I'm going to start with the square root of 32. Two perfect squares that 32 falls in between would be 25 and 36. So I know that when I estimate it, it's going to be in between 5 and 6 because those are the integers that represent the square root of 25 and the square root of 36. So a safe one to start with would be 5.5 times 5.5. Go ahead and work this problem out. And when you do, you should get 30.25. It's too low, so I'm going to go ahead and try 5.6 squared and see if that gets me any closer. Write it out. See you guys when you're done. Ta-da! 31.36. Now, this is still a little too low. It might be the closest we can get, but just to check, I'm going to do 5.7 times 5.7 and see if that gets me any closer. Go ahead and pause your screen. Alright, when I finally multiplied it out, I ended up with 32.49, so this is actually going to be our closest estimate, 5.7, as being the square root of the square root of 32. So for my notes, the approximation would be about 5.7. Alright, 5.51326, they want us to round that to the nearest tenth. So whenever you're rounding, you look at that place value that you want to round it to, look next door and see if that number is 5 or more. If it's 5 or more, this is going to round up. If it's 4 or less, it's going to stay the same, and you're just going to keep that tenths place the same. Since 1 is less than 5, this rounded would be 5.5. Step 3, plot them on the number line to compare them. Our 5.51326 will be here. Our square root of 32 will be at about 5.7. So our square root of 32 is going to be greater than our 5.51326, and so on. Example 3, compare and order rational and irrational numbers. So for this one, it gives us 5 rational and irrational numbers, and it wants us to place them on a number line in order to compare them. So a couple ones that you can simplify pretty quickly is this 9.5. You should know by now that 1/2 as a decimal is 0.5. So I can rewrite 9.5 as 9.5. When I put that on a number line, it's going to be right here. So I'm going to write it as 9.5. That's where it would be on my number line. 9.8 is already simplified for us as a rounded to the nearest tenth. It's going to be right here on our number line. So there's 9.8. Took care of that one. 9.5 repeating. You can write that as 9.555 and so on. When I plot that, it's going to be greater than 9.5 but less than 9.6. So that one's going to fall right here on our number line. And then for pi squared and the square root of 94, those are the ones that we're actually going to need to solve. So for pi squared, you should know by now that pi is written as 3.14 when rounded, and to multiply it by itself, or to square it, we are going to multiply it by itself. So I'm going to go ahead and work out this multiplication. Go ahead and pause your screen and do the same. Okay, when I ended up multiplying it, I got around 9.86, so it's going to be greater than 9.8, but less than 9.9, so on our number line, it's going to be right here. This is going to be pi squared. And then finally, the square root of 94. The square root of 94, we're going to have to do that the way we were doing the previous problems, setting it in between two perfect squares. So I know it's less than 100, which is a perfect square, but greater than 81, which means it's going to fall somewhere in between 9 and 10, which we knew by looking at our number line that it's going to be somewhere in between 9 and 10 also. So I'm going to start with 9.5 and go from there. So let's start with 9.5 squared, see what that gets us, and see what we need to change. So go ahead and work this one out. Alright, I ended up with 90.25, which is a little low, so I'm going to go ahead and try 9.7 and see what that gets me. So I'm going to do 9.7 squared. I'm going to work this out. You guys can go ahead and do the same. Alright, when I multiplied 9.7 times 9.7, I ended up with 94.09, which is really close to 94, so our estimate for the square root of 94 is going to be about 9.7. Okay, so when I put that on my number line, it's going to be right here. Alright, and the final thing is to put these in order from least to greatest. So I'm just going to do this. I'll do it in another color so we can kind of see what we're doing here. But so 9.5, oh, let me write it as the original number. So we have 9.5 is less than 9.5 repeating is less than the square root of 94, which is less than 9.8, which is less than pi squared. And that's how you would order them from least to greatest. All right, that's all I have for you. Have a good one.